Now we have to also talk about, there are something called peripheral chemoreceptors, and where are they located? And we're going to talk about that too, right? So for that one, we have to talk about our beautiful heart right here. So these guys are located where? So basically, if I quickly mention about this, right? So we have okay, so you have this guy here, okay, and then you have, what is this called, is and this is my, okay, that's going to be my pulmonary arteries, and I have to make this, as my aorta right here, and this is my aorta, okay? So this is arch of aorta, and remember, if you're arch of aorta, there's some blood vessels are coming out right here, right? This is arch of the aorta, right? I'm going to just draw one. They have this common carotid arteries, left common carotid arteries, and right common carotid arteries. Let's just make it one for our case. There's a common carotid arteries coming out, right? It could be right, it could be left common artery. This common artery, what's going to happen? One is coming from brachiocephalic trunk too, right? So let's just make this left common carotid artery, right? And this left common artery was going to split into two things. One is going to make what? It's going to go to the brain, right? And we call them a left internal carotid artery, another one we call them a external carotid artery, correct? So let's just make this as this. Okay? So, like down here, if I make this, let's just make this a little bigger with the, right here. Okay? So, if I make this right here, and then this is going to be, let's just make this a left, okay, external carotid artery, and this is going to be left internal carotid artery, okay? And this is a left common carotid artery. So basically right here you see, I draw this little thing coming out. These are called sinuses, and that sinus are the baroreceptors. We're not talking about this one. These are baroreceptors. They're about the blood pressure device measure. But what I'm talking about, there's some chemosensor cells which are located, they're oval shaped, like down here. Okay, let me make this in a blue color actually. These are right here. The blue cells right here, they're located right here, okay? These, and they're like body of the cells, okay? These are called, what do we call this as? These are called carotid body. Carotid body, okay? Now, there's a group of cells down here, and there's an oval-like shaped structures, and they're about, like, they're very, very small, okay? They're very small, like, you know, usually it's about like 12 milligram or something, and they're located around because it's a bifurcations of your internal carotid artery, right? On top of this is where those carotid bodies are present, and some of the, and then also there are also aortic body are located within the arch of aorta, like down here, something like this. Okay, this is called aortic body now. Okay, and these the bunch of cells, they're very, very sensitive to the chemical composition, chemical sense, and we'll talk about that too, right? And these guys are actually, let's just go and talk about it. These are a group of cells which makes the body of the cells, they're very, very sensitive to a couple of things, and I'm going to write it down. These guys are very, very sensitive to partial pressures of oxygen, okay, and then high level of carbon dioxide, and then also high level of your proton, okay? But these guys, especially these guys, aortic body, they're very, very sensitive to your partial pressure of oxygen when it falls at below like 60 millimeters of mercury, okay? So very, very sensitive, but they're also a little sensitive to carbon dioxide, H+, but mostly sensitive to the partial pressure of oxygens, okay? These chaotic body and aortic body, okay? So how does this work is that, and these guys, obviously, this aortic body and cardiac, but the way it works is they have supplies with this is going to be, this aortic body has a supply of the cranial number 10, and this is going to be cranial number 9, okay? And they will go to the, all the way to my dorsal respiratory group of nuclei right here. Make this as a different color, or make this as more in a red color, right? Sensory fibers to dorsal respiratory group of nuclei, okay? Axon potentials 5, okay? And this is going to be this is 9, and this is 10, other way around. It's a 9, and then this is a 10. So it will bring sensory information to the dorsal respiratory group of nuclei, and this will, guys, as you know, what are they going to go? There is going to be, okay, and as I said, right here, right? So basically, this guys will fires, right? And then obviously this will go the lower motor neurons, right? And you can even say this will give a fibers to down here. Okay? So that way you can increase the ventilation process, right? Because you want to increase the ventilations whenever you have a low level oxygen. What are you going to try? You increase the ventilation so you can bring more oxygen into it, right? That's what those guys do. But we have to understand that what is the mechanisms of this, how they sense it. Because normally what happens is that because these cells, okay, the group of cells, they're like a body of the cells, they're receiving, they have a very, very high flow to this body. Probably the highest flow in our human body, okay? They receive like so much of blood there, and so much of blood. So usually whenever these cells are like sensitive to, let's say, oxygens, then these guys will do certain things to actually do this process. And what is the mechanism? That's what we're talking about, right? So this cell, let me draw this cell. So let me draw this cells right here, because we do have to talk about the cells in little detail. So okay, let me just make this a little bigger. So let's just make this cell right here. Okay, these cells, there are two types of cells here. One is called, let me just make this cell. One of the cell is called, they're called type 1 cells and the type 2 cells. Let me make this type 2 cells here. They're called sustentacular cells, okay? Sustentacular cells, I don't know how to spell this, but they're called sustentacular cells. Basically, these are the supportive system of the sustentacular cells, okay? They're type 2 cells. And other cells where we are focusing on is called type 1 cells, and they're called glomus cells. And what is the role of glomus cells? We'll make these cells a little bigger right here, okay? So we'll make these cells a little bigger. So what happens with these cells is, okay, we'll make these cells a little bigger right here. So what is the role of these cells is right here. So these cells are called type 1 cells, which are called glomus cell, okay? And these guys are very, very sensitive to partial pressure oxygen, which is like low. So what these guys do is that, okay, so whenever there's a low level of oxygen here, right, what's going to happen is that these glomus cells have very, very good properties. One of the properties is that these guys they have these channels. Okay, these channels are called what? These channels are called potassium sensitive, like oxygen sensitive, sensitive potassium channel. Okay, so whenever these guys are receiving oxygen, okay, partial pressure oxygen, good, what happens is that these channels, the potassium, are always open. So what happens is always times the potassium efflux are happening, okay? Cell is going hyperpolarization happening, right? Cell is becoming less excitable. Okay, that's what's happening normally. Okay, now that's normal. But whenever these guys, what happens is that whenever these guys will receive like low level of oxygen, let's say, whenever these guys receive low level of oxygen, what happens is that the couple of things. So you have a low level of oxygen right here, a low level of oxygen, right? So whenever low level of oxygen happens, what happens? Somehow there is an elevation of cyclic AMP. Okay, the cyclic AMP. And what cyclic AMP does, it activates protein kinase A, right? And the protein kinase, when it put a phosphate group into this channel, this becomes inhibited. Okay? Whenever protein kinase A puts a phosphate group into this channel, but it becomes inactivated. That means this potassium, this protein kinase started closing. That's what I'm saying. Now, other thing happens is that whenever there's a low level of oxygen is right here, okay, one thing happens is that oxygen, okay, this what it does is that it inhibits this NADPH oxidase. And remember what does these guys do? Remember, which reduces the rising level of your oxidized glutathione. Okay, so you reduce the rising level of oxidized level of Sg, right? So because of that, what happens is that this will also inhibit this channel. So inhibit the NADPH oxidase, right? Which reduces the rising level of oxide of glutathione, okay, and that also inhibits this guy. And other thing it does is that whenever there's a lot of oxygens, remember, oxygen get deassociates from, okay, let's just make it down, maybe down here. Oxygen get deassociates from hemoglobin, okay, hemoglobin protein. So in that case, what happens is that oxygen get deassociates near the hemoglobin protein, and that also, let's just make this as a hemoglobin right here. Okay, let's just make this as a hemoglobin right here. One pocket here, okay, and then 3. So whenever oxygen get deassociates from here, what happens? It also inhibit this way. So there are three mechanisms when the participatory oxygen goes down. One is that whenever the cyclic AMP level goes up, and that inhibits this potassium sensitive oxygen channels. And the other one is that because it inhibits low level oxygen, inhibits the NADPH oxidase, and because of that you're gonna have a reduced rising oxidized glutathione. And other one is that when the oxygen dissociates from the hemoglobin proteins, right, near the potassium channels, it also inhibits these channels. Okay, this is the one thing. So whenever this, let's say now this channel is, we'll cross this out and we'll say this, okay, this channel is inhibited now. If this channel is inhibited, what's going to happen is that if this channel is inhibited, then what's going to happen? The cell is not going to go to hyperpolarized anymore. So what is going to happen is that the potassium channels are going to start building up inside the cell. When the potassium channels start building up the cell, what's going to happen? The voltage gated right here. Let's make this as a right here. The voltage gated, this voltage gated potassium channel, voltage gated calcium channels opens up. So whenever the voltage gated calcium channel opens up, what happens? Calcium will rush in. Calcium comes in. Okay, the calcium will comes in, and this large amount of calcium that's going to trigger. Okay, there are some vesicles right here. I'll make a different color. There are some vesicles present down here, and these vesicles right here, let's just make these vesicles. There are a lot of vesicles there. This vesicle contains some neurotransmitters, especially something called dopamine. Okay, the dopamine is there. So what happens is when the calcium channels stimulate dopamine is going to go. Dopamine gets stimulated, and what happens is that they'll go and then they will get released from exocytosis happens, and then the dopamine, this vesicle fuse to the membrane of the cells, and then dopamine will release. And then when the dopamine release, what's going to happen? It goes, guys, it's so interesting when you know, right? So when dopamine gets released, what's happening? It goes and binds to its receptor, the postsynaptic receptor. Where is it bind? It goes and binds to the receptors are located where? To the glossopharyngeal and the vagus nerve right here, you see? So the receptor, bind the receptors, because the receptors for the dopamine those are afferent fibers of your glossopharyngeal number 9, right? Or the 10. So they will bind to let's just make this as this receptors right here. This is a receptor. Okay, afferent receptors for dopamine, they'll go and bind, and then they'll send the impulses down here to the dorsal respiratory group of nuclei, and that will cause increase in ventilations, right? So that way you want to take the more air in, okay? So that way, you want to take more air in. That's one of the mechanisms that glomus cells do. As I said, and this is because of the low, again, partial pressure of oxygen, right? Now, but as I said, remember I said, this glomus cells, the type 1 cells, they're very, very sensitive to the low partial pressure of oxygen. But I also said they're also sensitive to less sensitive, but there's the high level of carbon dioxide and then high protein concentrations. And how does that work is that, look, here, these channels, okay, what happens is that, okay, look, whenever the carbon dioxide comes in, right? So let's make this as a different color right here. So what happens is that whenever there's a high level of carbon dioxide is right here, okay? Whenever high level of carbon dioxide is there, what happens? The carbon dioxide can easily go through the cell membrane, okay? And this carbon dioxide, when it goes here in the cell, it mixes the water of the cell, okay? and there's an enzyme called carbonic anhydrous enzyme, and makes carbonic acid, and this carbonic acid splits into what? H plus, and then also bicarb. Okay, and this H plus is the one that does not like this. This H plus, what it does is it's inhibit the channel. Okay, inhibit the potassium channels. Okay, because the high level of H plus is going to inhibit the channels. So if you inhibit the channels, potassium will build up, and that's how the action potential will happen. And then the voltage gated calcium channels will also open up. Other thing is that, remember I said that pH. Okay, let's just make this right here. Okay, I'll make the cells laid out differently. Okay, sorry for this, but then I have to, okay, hold on. Okay, I'll just make here. So what happens is that there are channels in these cells, special. There are two types of channel right here. One channel is called, in the cell, they have a channel called sodium plus proton exchanger. Is that exchanger, okay? So what happens is, often like sodium is coming inside the cells right here, and then what is potassium is going out. Sorry, proton is going out. This is what it is. So really what happens oftentimes is so you have a sodium and proton exchanger. Basically what is it? Your sodium is coming, this is an antipode, right? So sodium is coming in and the proton is coming out normally, what happens. But whenever there's a high level of proton, meaning what? Low pH, right? So whenever the high level, so low pH is there, okay? Low pH is there. So what's kind of low pH? It inhibits this channel. So when it inhibits this channel, what's going to happen? If it's inhibits the channel, the potassium is going to first build up. Other thing it does is that it also opens up, there's another channel down here. The channels, let's just make this very small, okay? The channels right here is present right here. Okay? The channel is actually proton channels. Okay, proton channels. So this allows this more proton to flow inside the cell, okay? Because allows low pH, allows this proton to be activated, and more proton can go. And when you have a lot of protons, H plus is building up, what it does, if you see this, it also inhibits the channels. Okay, so this is how this oxygen sensitive potassium channels actually closes, and then because of that, more potassium will build up inside the cell. That will make the cell less negative, less excitable. Okay, so because of that, what happens is that the cell will start depolarizing. The cell is going to lose its polarity. That's what we call the depolarization, right? And the action potential happens. The voltage gated calcium channels open up. Both are gated calcium channels. That when they come, the large trigger those vesicles, and then dopamine triggers dopamine to release, and through the excitatory process, dopamine goes and binds to the receptors at the nerve endings of your glossopharyngeal nerves, and then that's how it brings the stimulation to your dorsal respiratory group of nuclei. Okay, and that's how this dorsal respiratory group nuclei will, if it's powerful stimulator, what's going to happen? It's going to overspill. Remember, as I talked about it, also that the ventral respiratory group or the expiratory nuclei, but morely it's a pre-Buttinger nuclei, okay, that has to do with the inspiratory muscles, right? And then it will overspill that, and then that will cause to have increase in ventilations, okay? It will cause more intense respirations. That's what it does.